Do a project like this really comes down to the partners that we work with. And this is a complex engineering project with multiple companies involved, bringing together the newest technologies, but also putting a lot of thinking into this as an engineering group.
We tried to figure out what elements we wanted to make sure were incorporated. So the independent cart technology was absolutely key to this, and that was something that Michael kind of insisted we had. What does the university need? What do our business leaders need as far as the partnership goes? What would we need for research? So we Haskell down in Atlanta to develop a functional specification for everything we could consider. And then that became the guiding document to tie everything together. How many different forms of learning can we apply on a single machine? That was really the basis of it.
You mentioned some things that we've never done as APT. There's things on this cell that have never been done, period. PLC motion let the PLC actually control the robot motion at a granular level. We were actually able to hook up Fanuc's RoboGuide to the physical PLCs and do a lot of debug and emulation prior to. And what's unique about that is we had all 4 robots running in one RoboGuide simulation tied up to the multiple PLCs. So we have a safety PLC, we have the robot PLC, and then a process control PLC all talking together and talking through RoboGuide.
To set some standards and some methodologies that we could scale and repeat for other industries as well. I thought about this as structure with engineering design, with repeatability, with end-use applicability.
As far as programming the MagnaMotion, we got a lot of help from the MagnaMotion folks at Rockwell. It's amazing what that thing can do as far as just doing its own little self-traffic control, the speed at which it functions. We've actually had to slow that thing down to about 50% capacity because otherwise the vials and the caps on the system will fly off as it goes around corners. Latest, greatest technology, so the new Panel V5000s are out there, the L8 controllers are there, the brand new color sensors, we're using those for the dry fill capsules, so they will determine the different colors. It's the future of manufacturing.
We've been longtime partners with Enders and Hauser. We have so much trust in E&H and the way they operate and their partners.
Symbiont's aspect involves the liquid delivery portion, and really what we're trying to do is give the university some variability, both from a controls perspective and from a mechanical perspective, so that we can look at how things like varying mechanical designs, varying controls methodology, how network latency, things like that affect real-time high-speed controls, and then be able to integrate the analytics that we're looking at and say, at what pressure can we optimize this skid? Which of the 3 filling methods is the most accurate? How do we want to control our valves?
There's so much potential that can be unlocked here for learning, for applied research, for creating value. It's ready to accelerate the upskilling of US manufacturing, really to open people's eyes up to what is digital manufacturing, what does that really mean. The credit actually goes to our management team, and it really trusted us to go get this done.